Has Lewis Hamilton betrayed the spirit of F1? The revelation that Lewis Hamilton has been secretly forging partnerships with tech giants like Google to integrate quantum computing into Mercedes cars has sparked an unprecedented debate. While some applaud him as a visionary genius, others wonder, is Lewis redefining engineering, or is seven-time world champion Lewis Hamilton distorting the spirit of a Formula One sport that has always valued human skill over extreme technological superiority? Is this a masterstroke or the beginning of an era where races are won by algorithms, not drivers? The fine line between innovation and unfair advantage has never been so blurred. Sunlight streamed through the floor-to-ceiling windows of the Mercedes-AMG Petronas Formula One team headquarters in Brackley, illuminating dust motes dancing in the air and the sheen on the polished conference table. A hum of focused activity could be felt even through the thick walls, the controlled chaos of a top-tier racing organization. Toto Wolff, ever the picture of composed intensity, sat at the head of the table, flanked by key personnel. The atmosphere was charged, but not with the usual pre-race tension. Instead, a peculiar kind of anticipation hung in the air, a mix of intrigue and genuine bafflement. Lewis Hamilton, not in his usual race overalls but a sharp, tailored suit, stood not beside an engineer, but as one, holding a detailed technical schematic. He gestured to a complex diagram illustrating a novel energy recovery system, his voice clear and articulate as he explained its theoretical benefits. This wasn't a PR stunt or a simulated exercise. This was Lewis Hamilton, the seven-time world champion, presenting a genuinely revolutionary engineering concept to his own technical team. The team, accustomed to his unparalleled skill behind the wheel, exchanged bewildered glances, their expressions a cocktail of respect, surprise, and a hint of professional skepticism. This was a narrative arc no one had predicted. The silence in the room stretched, punctuated only by the soft whir of the projector and the occasional rustle of a notepad. Lewis, undeterred by the palpable surprise, continued his presentation. The core principle, he articulated, tapping a specific section of the schematic with a laser pointer, revolves around a reimagined thermal efficiency transfer within the power unit. We're looking at harvesting minute kinetic energies previously dismissed as negligible losses, and converting them into usable electrical charge through a series of microgenerators integrated directly into the exhaust manifold. He then elaborated on the specific materials he had researched, mentioning a newly developed alloy, Chronicin 5, known for its unparalleled heat resistance and piezoelectric properties, a material that had only recently moved from advanced theoretical physics labs into practical application. Andrew Shovlin, the team's trackside engineering director, a man whose life revolved around the minutiae of car performance, leaned forward, his brow furrowed in concentration. He was known for his analytical prowess and a keen eye for detail, and even he seemed genuinely stumped. Lewis, Shovlin began, his voice a mix of respect and disbelief, the simulations we've run on similar concepts, even with hypothetical materials, consistently showed efficiency gains that were statistically insignificant, or worse, introduced prohibitive weight penalties. How have you addressed those fundamental hurdles? Lewis smiled, a genuine, almost mischievous glint in his eye. That's where the paradigm shift comes in, Andrew. It's not about brute force energy harvesting. It's about a symbiotic integration. The Chronicin 5 isn't just a heat sink, it's an active participant in the energy cycle. And regarding the weight, he paused for dramatic effect, my calculations suggest a net weight reduction of approximately 0.7 kilograms per unit, due to the elimination of several existing, less efficient components that this system renders obsolete. He then delved into complex thermodynamic equations, sketching out derivations on a digital whiteboard with an ease that belied his profession, citing recent advancements in quantum tunneling for enhanced energy transfer and referencing articles from obscure scientific journals that even some of the most seasoned engineers present hadn't yet encountered. The room, initially stunned, was now captivated. Even Toto Wolff, who had seen countless innovations cross his desk, found himself leaning forward, a rare flicker of pure awe in his eyes. This wasn't just a driver dabbling in engineering. This was a formidable intellect, unleashing a torrent of truly disruptive ideas. The implications for the 2026 technical regulations, which were still being hotly debated within the FIA, suddenly seemed incredibly pertinent. The air in the Mercedes Technical Center conference room, usually buzzing with the controlled murmur of engineers debating performance metrics, was now thick with an almost reverent silence. Lewis continued, the real breakthrough, however, lies in what I've termed adaptive kinetic capacitance. Imagine not just storing energy, but actively adjusting the system's impedance in real time, based on predictive analytics of track conditions and driver input. He then projected a sophisticated predictive algorithm, its lines of code sprawling across the screen, explaining how it could anticipate moments of high braking or acceleration, optimizing energy recovery and deployment with unprecedented precision. This isn't merely about recuperating wasted energy, Lewis emphasized. It's about transforming the car into a truly intelligent, self-optimizing energy platform. We're talking about micro-adjustments happening thousands of times a second, far beyond human perception or even current telemetry capabilities. John Owen, the chief designer, typically a man of few words and precise calculations, finally broke the spell. "Lewis," he said, his voice slow and deliberate, "the level of integration and computational power required for adaptive kinetic capacitance is astronomical. We're talking about onboard processing that rivals supercomputers. How do you propose we implement that within the existing power unit architecture and, more critically, within the current cost cap restrictions?" His question hung in the air, a valid engineering hurdle. Lewis didn't miss a beat. "That's where the partnership with Google's quantum computing division comes in," he stated, dropping a bombshell that sent a ripple of murmurs through the room. "I've been in discussions with their advanced research team for the past 8 months, exploring how their nascent quantum processors, scaled down for automotive application, could handle the processing demands. Their latest breakthroughs in error correction for quantum entanglement make it feasible. The initial prototypes show a processing speed increase of over 1,000 times compared to our current best-in-class ECUs, all within a footprint roughly the size of a standard laptop battery. And as for the cost cap," he added, a wry smile playing on his lips, "Google is as keen as we are to see this technology deployed. They're willing to absorb a significant portion of the development costs as part of a long-term strategic partnership, seeing it as a pioneering demonstration of quantum computing's real-world application." The revelation of a secret collaboration with a tech giant, a partnership initiated by their star driver, left everyone, including Toto Wolff, utterly flabbergasted. This wasn't just about a new car part. This was about a fundamental shift in how a Formula One team could leverage external, cutting-edge technology, completely bypassing the traditional procurement and development channels. It was a testament to Lewis's vision, his relentless pursuit of excellence, and his uncanny ability to connect seemingly disparate fields of innovation. A collective gasp, quickly suppressed, spread through the room. The notion of Lewis Hamilton, the global icon and racing superstar, secretly forging alliances with tech titans like Google for quantum computing applications in Formula One, was almost unfathomable. Toto Wolff, ever the strategist, leaned back in his chair, a slow smile spreading across his face. This was a disruption he hadn't anticipated, one that could redefine the very essence of competitive advantage. "Lewis," Toto began, his voice laced with a mixture of pride and genuine astonishment, "this is audacious, beyond anything we could have imagined. How did these discussions even begin? And why the secrecy?" Lewis adjusted his stance, his gaze sweeping across the faces of his engineers, a silent acknowledgement of their initial skepticism now giving way to dawning comprehension. "It started subtly," he explained. "My interest in sustainable energy and advanced computing isn't new. I've been investing my own time and resources into understanding these fields for years. During some of my downtime, instead of just focusing on physical training, I immersed myself in academic papers, attended virtual conferences on AI and quantum mechanics. A mutual contact, a professor at MIT I'd met through a sustainability initiative, introduced me to some of the lead researchers at Google's quantum division last year. What began as informal conversations about theoretical applications quickly evolved when they saw my understanding of motorsport's unique energy challenges. They recognized the real-world proving ground F1 offers for their nascent technology." He paused, letting the weight of his words settle. "As for the secrecy," he continued, "it was paramount. In a sport where intellectual property is fiercely guarded, any hint of this collaboration, especially with such groundbreaking technology, would have been immediately pounced upon by rivals. We needed to develop the core proof of concept in a completely insulated environment. The simulations, the preliminary hardware designs, all of it was done under strict non-disclosure agreements, using external, secure facilities that only a handful of individuals had access to. We couldn't risk leaks. The competitive advantage hinges entirely on being first to market with this." He gestured back to the schematics. "The integration of this quantum processing unit, codenamed Project Tachyon, isn't merely about faster calculations. It enables a completely new approach to predictive modeling for tire degradation, fuel consumption, and even aerodynamic drag in real time. Imagine the car predicting the optimal slip angle for the next corner based on live track data and tire temperature, not just from pre-programmed algorithms, but from a quantum-enhanced, constantly evolving learning model. That's the leap." The room was no longer just surprised. It was captivated, a sense of awe mingling with the frantic mental calculations of how this would fundamentally alter the landscape of Formula One. This wasn't just Lewis Hamilton the driver. This was Lewis Hamilton, the visionary, the technological disruptor, unveiling a future they hadn't even dared to dream of. The whiteboard, now displaying intricate diagrams of quantum circuitries and predictive algorithms, became the focal point of the room. Lewis, with the effortless command of a seasoned professor, walked his team through the proposed implementation timeline. "Our initial phase, already well underway, focuses on miniaturization and robustification of the Project Tachyon quantum chip for the extreme demands of an F1 environment. We're talking about G-forces exceeding 6G, vibrations that would shatter conventional electronics, and temperatures that fluctuate wildly. Google's engineers have made remarkable progress in developing specialized cooling solutions and shock-absorbing substrates, building on their expertise in extreme computing environments. He then switched to a new slide, displaying a detailed project Gantt chart. Phase 2, commencing next month, involves integrating a preliminary version of the quantum processing unit, a proof-of-concept iteration, into a modified test mule at our private testing facility in Silverstone. This isn't about setting lap records, he clarified, anticipating the immediate thought, but about real-world data acquisition and validation. We'll be running extensive telemetry to compare the quantum-enhanced system's predictions against actual car behavior, refining the adaptive algorithms based on live feedback. This will allow us to stress test the Chronoson 5 energy recovery system in tandem with the quantum processing, ensuring seamless communication and optimal power flow. Andrew Shovlin, having absorbed the initial shock, now saw the practical implications. So, this would effectively give us real-time, dynamic car setup adjustments, he queried, his engineer's mind already racing ahead. Not just pre-programmed maps, but the car actively optimizing its own parameters during a stint. Precisely, Andrew, Lewis affirmed, a rare, genuine grin breaking through his composed demeanor. Imagine the car making micro-adjustments to brake bias, differential settings, and even suspension stiffness, not based on fixed telemetry points, but on a constantly updated, quantum-derived prediction of the optimal state for every millisecond of the lap, adapting to tire wear, fuel load, and even subtle changes in track temperature or grip. It's about moving from reactive control to truly proactive, self-learning car performance. This isn't just an upgrade, it's a paradigm shift in vehicle dynamics. His words painted a vivid picture of a future F1 car that was, in essence, a sentient entity, constantly learning and evolving its performance on the fly. The engineers in the room, initially skeptical and then awestruck, were now genuinely excited. The potential competitive advantage was staggering, a prospect that overshadowed even the audacity of Lewis's secret endeavor. The implications for the 2026 technical regulations, which were aimed at leveling the playing. Toto nodded, his gaze fixed on the digital clock, which now read 12:45 p.m. on June 10, 2025. Indeed. And the timing couldn't be more critical. With the upcoming regulations in 2026 emphasizing greater sustainability and technological innovation, Project Tachyon positions us not just as a leading racing team, but as a technological vanguard. It's a statement of intent, a declaration that Mercedes-AMG Petronas is not just reacting to the future, but actively shaping it. He paused, then added, "Just imagine the headlines when this becomes public. Hamilton's quantum leap. It will be legendary." Lewis chuckled. "Let's make sure it's the on-track performance that does the talking first. The true legacy will be in the data, the gains, and ultimately, the championships this technology helps us secure." As they walked out of the conference room, the sounds of renewed activity from the technical center now seemed imbued with a new sense of urgency and excitement. The unexpected rise of Lewis Hamilton, the engineer, had not just challenged the status quo, it had irrevocably altered the trajectory of the Mercedes-AMG Petronas Formula One team, setting them on a course towards a future driven by quantum-powered ambition. The race for technological supremacy had just been redefined, and in Brackley, on this seemingly ordinary Wednesday, the future had definitively begun. Field suddenly seemed entirely moot. Lewis Hamilton hadn't just found a loophole. He had, with the help of a tech giant, envisioned an entirely new game. Toto Wolff, who had been listening with an increasingly expansive grin, finally spoke, his voice cutting through the hum of excited murmurs. "Lewis," he said, pushing himself up from the table and walking over to stand beside his driver, a hand resting on his shoulder. "This isn't just an engineering presentation. This is a strategic blueprint for the next decade of Formula One. It's a testament not only to your vision but also to your incredible dedication outside of the cockpit. The initiative you've shown in forging these partnerships, in pushing the boundaries of what a racing driver can achieve, it's truly remarkable." He turned to the assembled engineers, his expression now serious, almost conspiratorial. The secrecy, as Lewis rightly pointed out, has been critical. But now, as we move into physical prototyping and integration, the circle of knowledge must expand. Our entire team will need to embrace this. It requires a fundamental shift in how we approach vehicle development, data analysis, and even driver training. We will need cross-functional teams, integrating specialists from areas we haven't traditionally focused on. This isn't just about fitting a new component, it's about re-engineering our entire operational philosophy. Toto then pointed to the digital clock, indicating the current date, June 10, 2025. Today marks a pivotal moment for Mercedes-AMG Petronas. We are not just building a faster car, we are building a smarter, more adaptive racing machine. This Project Tachyon, the name itself speaks to incredible speed and ambition, represents a leap forward that could redefine the sport. Our rivals will eventually catch on, of course. But our goal is to establish such a significant lead in this quantum-enhanced adaptive technology that by the time they even comprehend its full scope, we are already several steps ahead, refining and evolving it further. This will demand unprecedented levels of collaboration, discretion, and relentless innovation from each and every one of you. The palpable shift in the room was electric. From initial surprise to a growing excitement, now a profound sense of shared purpose settled over the team. Lewis Hamilton had not just presented a technical solution, he had ignited a new era of ambition within the most successful team of the modern F1 era. The race, it seemed, was no longer just on the track, but in the very fabric of technological advancement. The meeting continued, transitioning from Lewis's grand reveal to a more granular discussion led by Toto Wolff, outlining the immediate next steps and the unprecedented level of integration required. From this moment forward, Toto declared, his voice resonating with authority, Project Tachyon becomes our primary, confidential strategic initiative. All resources, human and technological, will be prioritized accordingly. Andrew John, he nodded to Chauvelin and Owen, you will co-lead the core development team, reporting directly to me. We need to establish a dedicated, secure development lab, completely isolated from our regular operations, for the physical integration of the quantum processing unit and the Chronoson 5 system. This facility will have restricted access, with only cleared personnel permitted entry. Security protocols will be paramount. No external devices, no unauthorized communications. He then addressed the wider engineering group. This also means a significant upskilling program for many of you. We will be bringing in specialists from Google's quantum division for intensive training sessions on quantum architecture, data handling, and the predictive algorithms. We will need our aerodynamicists to think in terms of dynamic aeroelasticity, influenced by instantaneous, quantum-driven calculations. Our simulation engineers will have to adapt their models to account for a car that is constantly optimizing itself beyond pre-programmed parameters. This is a challenge that will redefine your roles and push your capabilities beyond anything you've experienced. Lewis, now seated, interjected, and I want to be deeply involved in every phase of this. Not just as a driver providing feedback, but in the development process itself. My understanding of the car's nuanced behavior on track, combined with the theoretical knowledge I've gained, can bridge the gap between concept and application. I'll be working closely with the simulation team, validating the quantum models against my own driving data, and helping to refine the predictive algorithms to truly capture the feel of the car. This isn't just a technical upgrade, it's about creating a symbiotic relationship between driver and machine, enabled by this new level of intelligence. Toto nodded approvingly. Exactly, Lewis. Your unique perspective will be invaluable. We are effectively creating a digital twin of the quantum-enhanced car, one that learns and evolves with every simulated and real-world kilometer. The datasets we will be collecting, processed by Project Tachyon, will be enormous and incredibly complex. Our data analysts will become more akin to quantum data scientists. This also has implications for our driver training. George Russell will also be brought into the fold, and we will begin integrating Project Tachyon's principles into our simulator work in a highly controlled environment. The goal is to make both drivers instinctively understand and maximize the capabilities of a car that is constantly thinking and adapting. The ambition in the room was now palpable, a powerful current of shared purpose, united by Lewis Hamilton's audacious vision and Toto Wolff's strategic genius. The future of Mercedes in Formula One, it seemed, was about to be quantum leap ahead. The meeting, which had already stretched well beyond its allotted time, concluded with a palpable sense of renewed energy and purpose. As the engineers began to disperse, a low buzz of excited chatter filling the room, Toto Wolff held Lewis back for a private word. Lewis, he began, his voice softer, more personal, what you've brought to the table today, it's not just a technological advantage. It's a complete shift in perception. Not many people understand the depth of your interests outside of racing, the sheer intellectual curiosity that drives you. This project, it redefines what a Formula One driver can be. Lewis smiled, a genuine, almost humble expression on his face. For me, Toto, it's always been about pushing boundaries. Whether it's on track, or trying to understand the science behind what makes these machines perform. I've always believed there's more to discover, more to optimize. And the idea of leveraging truly cutting-edge technology, not just for performance, but for efficiency and even sustainability, that's incredibly motivating. The partnership with Google isn't just about winning races. It's about showcasing what's possible when different fields of innovation converge.